All right, hi 333. This is a lesson for May 8th. So what we're talking about today is called exponential growth and decay. These often do show up in one or two problems on the algebra exit exam, and you guys actually saw it already in one of those shorter response questions on the algebra exit exam 1 that we just did. So we're going to start to talk about that a little bit more. So if we're looking at this, it's a bit of a word problem. So in it, it says that 10 people received a chain letter and we're told that they need to send it to 10 more people that haven't received the letter by next week, or else they will have bad luck for 7 years. They each send their letter to 10 more people the following week. This pattern continues. How many people will have received the letter by the 6th week, right? So what we have to do here is we got to start to look at what is going on. So I started to draw a little bit of a picture. So it started with those original 10 that got it. Then they each sent it to 10 people. And then those 10 people each sent it to 10 people. And this would continue on for 7 weeks or 6 weeks, right? So what I think would be helpful here is probably making a table. So in week 1, we know that there's 10 people. Now, each of them send it to 10 more people. So we're going to have to do 10 times 10 or 10 squared, and that's going to be 100. And then we're going to have to do each of those people times another 10. So 100 times 10 or 10 times 10 times 10 is going to be 1,000. So week 3 is going to be 1,000 people. Okay, so I'm kind of writing it out like this. So that means at week 4, we're going to have to times that by 10. So that's going to be 10,000. At week 5, we're going to have to times that by 10. So that's going to be 100,000. And finally, for week 6, we're going to times that by 10. And that's going to be 1 million. Now, this might be coming back to you with scientific notation, which is probably what I would think about too if I was thinking about this. And finally, they're asking how many people will receive it. So you'd have to add those up. So 10 plus 100 plus 1,000 plus 10,000 plus 100,000 plus a million. So that would be 1,100,000, 11, 111, or no, 110, all right? So it would look like that many people, which is a whole ton of people. Because if you think about it, the city of Chicago is only about 3 million people. So it would be like a third of the people in Chicago, which is a lot. Can you develop an equation that would represent the total amount of people with the letters in the nth week? Okay, this is going to take some thinking. So you're thinking, okay, well, each time we're multiplying by 10, right? So that would be 10 to the something power, so 10 to the nth power. And then you would be adding that eventually all together. But right now, we're just going to be focusing on that 10 to the nth power. All right, so an exponential is some kind of value that increases very quickly or that decreases very quickly. So exponential growth would be something that increases a lot really fast, like this problem right here, how it went from 10 people and 6 weeks later, it was over 1 million people that had the chain letter or whatever. Whereas exponential decay is when you start high and you go down really fast. So sometimes money or things like that you might want to think about. So these are actually really useful when you're talking about actual things happening. So if we're looking at here, it says which of these is linear and which of these is exponential. Well, since we just learned that exponential is increasing really quickly or decreasing really quickly, if I look at this right here, I can see that this, I'm adding 7, I'm adding 7, I'm adding 7. I wouldn't consider that really quickly. And because it's changing by the same amount every time, that tells me it's probably going to be a line. Whereas over here, I'm adding 2, and then I'm adding 6, and then I'm adding 18. But really, you might notice a different pattern, which is each time you're multiplying times 3. So times 3, times 3, times 3. So that's an exponential. And so what you guys will start to realize is that exponentials have to do with multiplying, whereas linears or lines have to do with you adding or subtracting. So that's the big difference here. So this one is linear, is because you're adding 7 each time. And this one right here is exponential. And so that is because you are multiplying by 3 each time. All right, so now we're going to start to graph some of these and see what do they look like. specifically with growth or decay. So we're going to try to determine if it's going to be growth or if it's going to be decay. So remember, growth is going up, decay is going down. So if we look at this original equation, we've got y equals 2 to the x power. That's going to be multiplication, because if you think about it, 2 to the third power is 2 times 2 times 2. 2 to the fourth power is 2 times 2 times 2 times 2, right? So let's go ahead and let's figure this out. So if we were to plug in -2 for x, that would be 2 to the -2 power, 2 to the -2 power, which is going to be equal to 1 over 2 to the second power, because anytime that there's a negative exponent, we change it into a fraction, which is going to be 1/4. All right, so that's where we're starting off. All right, next one, to the -1 power, 2 to the -1 power, that's going to be 1 over 2 to the first power, which is going to be 1/2. 1/2. 2 to the 0 power, well, anything to the 0 power is 1, so I don't even have to do the math. 2 to the first power, well, that's just 2. 2 to the second power, 2 times 2, that's 4. 2 to the third power, 2 times 2 times 2, which is 8. And 2 to the fourth power, 2 times 2 times 2 times 2 times 2, 16. All right, so let's graph what this looks like. So at -2, I'm going to be at 1/4. At -1, I'm going to be at 1/2. At 0, I'll be at 1. 1, I'll be at 2. 2, 4. 3, 8. And 4, 16. So I notice that this right here is going up very quickly. So this is going to be considered exponential growth. Now, this little part that's over here, it's going to go on forever, but it's never going to actually cross the x-axis. So it's going to get as close as possible to that x-axis and go on forever. If you guys have seen the movie Mean Girls, there's that part where Katie is doing that math competition, and in it she's like, oh, the limit does not exist. And that's because it's never going to cross the x-axis. So this is actually related to what she was doing there. So this is called exponential growth because it starts out low and it goes up really quickly. So let's write that down. So this is called exponential growth. Perfect. All right. This is actually how people get rich. They use interest rates and they gain money by having money either in banks or in stocks or things like that. And so this is how a lot of people get rich, is they figure out what is going on with exponential growth. All right, in the next one, we see that this time we have y equals 1/2 to the x power. Now, if you wanted to use 0.5 instead of 1/2, that's fine. You know that they mean the same thing. All right, so first one, we're going to be doing 1/2 to the -4th power. Well, that means that we're going to have to flip it, right? Because whenever it's going to be negative, it's going to become a fraction. So in that, we're going to flip it, so it's going to become 2 over 1. And then we're going to take that to the 4th power. Well, that's going to be 2 to the 4th power, which we just looked at over here is 16. All right, -3. So 1/2 to the -3 power is going to be the same as 2 over 1 to the 3rd power, which is 2 to the 3rd power, which is 8. Okay, so we're looking at that right there. We'll put in 8. Okay, 1/2 to the -2 power. That's going to be the same as 2 over 1 to the 2nd power, which is 2 to the 2nd power, which is 4. All right, to the -1 power. That's going to be the same as 2 over 1 to the 1st power, which is simply 2. Anything to the 0 power is 1. Done. 1/2 to the 1st power is 1/2. All right, now 1/2 to the 2nd power. So what we're going to have to do is we're going to have to do 1/2 times 1/2. Well, 1/2 times 1/2 is 1 times 1 and 2 times 2, which is 1 over 4. So we get 1/4. All right, and you're going to keep going, and then you'll do 1/2 times 1/2 times 1/2, and you're going to get 1/8. And then you're going to get 1/2 times 1/2 times 1/2 times 1/2, which is going to be 1/16. All right, so now let's take a look at what this looks like. So -4/16, -3/8, -2/4, negative 1, 2, 0, 1, 1, 1/2, and then 1/4, and then 1/8, and then 1/16. And it's, notice it's getting closer and closer to the x-axis. And just like in the other case, it's never actually going to cross the x-axis. It's just going to get closer and closer and closer. So I'm going to draw on a curve that kind of matches with these points. And I see that it looks like this. This right here is called exponential decay because it starts off high and then it decreases pretty quickly. Okay, so we're going to write that out. Exponential decay. All right, so I'm going to leave you here. What I would like you to do is go through the rest of these. I want you to predict which ones are going to be exponential growth and which ones are going to be exponential decay. All right, I'll put the answers up onto the document. All right.